So hello everyone, my roll number is 54 and today me and my team is going to represent the presentation on the design and implementation of the combinational logic circuit that detects an error in the representation of the decimal digit in the BCD. So means if I transfer decimal digit in the BCD, then how will it detect the error we have to see. So here the content line of my presentation. First we will see the introduction of BCD, then the truth table. In the truth table, we will see how we detect the error, and in the KMap we will just put the values from the truth table and generate the equations. And in the circuit, we will again draw the circuit diagram from the equation, and at last the implementation. So first see the introduction. So in the BCD numbering system, the given number decimal number is segregated into chunks of the 4 bits. Means for the each decimal number, if we converted decimal number to the BCD code, then our then it will segregate it into chunks of the 4 bits. So if I take the example, like I have to convert 1 to 3 in the BCD. So then I will just take the decimal number 1, which have the its BCD code 0001, and then 2, which has its BCD code 0010, and then again 3, which has BCD code 0011. Thus my total BCD becomes 0001, 0010, and then 0011. So then this is the perfect definition for to detecting error while converting decimal number to the BCD number. So here we know that the decimal digits in the BCD from 0 to 9, and it will detect the error when the number it will be greater than the 9. Then how we detect the error if the number is greater than 9? We will be seeing it by truth table.
Hello friends, my roll number is 63. To see the truth table of the representation of the decimal number in BCD code, we have see the decimal number inputs are 4 bits S0, S1, S2 and S3, and there are output. We know that 0 to 9 the BCD code is valid, and up to greater than 9 the BCD code is invalid. This is a 0 to 9 the BCD code is valid, then output is 0. But 10 to 15 the BCD code is invalid, then output is 1. This is the error detect. Then this is a truth table of the representation of the decimal number in BCD code.
Now from the truth table we have a output such as from 0 to 9 it's 0, and from 10 to 15 it's 1. Here we have a 4 variable, so by using KMap for 4 variable S1, S0 and S3, S2, put up the 1 from 10 to 15 in an KMap. So from the KMap we can see that the grouping, first one is a quad grouping. From quad grouping we get a just take it a S1 common from the row and S3 common from the column, we get the S1 and S3. And from the row we get from the row of ones we get a S3 and S2. So the generating form of a KMap is S3 S2 plus S3 S1. So that's it, KMap for the decimal to BCD truth table.
Now let's move towards the circuit diagram of BCD adder. Here we have used 3 logic gates, 2 AND gate and 1 OR gate. The inputs here are S1, S3, S2 and S3. Now looking here, S1 and S3 are the input, and here an AND gate is applied, so we will get S1 dot S3. Similarly, here S2 and S3 are the input. Here also an AND gate is applied, so we will get S2 dot S3. Now considering both of them, we have applied an OR gate to get our required output. We will get S1 dot S3 plus S2 dot S3. That is our output for BCD adder, that is Y is equal to S1 dot S3 plus S2 dot S3.
Hello friends, my roll number is 62. So this is the combination circuit that detects an error when we represent the decimal number into BCD. My friend already discussed about the truth table and the circuit diagram. So this is the To implement the combinational circuit, we firstly require the two ICs. First is the AND gate and second is the OR gate. And after that we require one LED, one resistor with breadboard and some wires, and also we require one power supply. Now we verify the truth table. We already know the BCD code is valid between the 0 to 9. After when we get the input between 0 to 9, then we get the output will be 0. If we get the decimal that greater than 9, so we get the output is 1. Now we verify the conditions in the truth table. Firstly we implement the circuit diagram with the help of the circuit diagram. Then suppose this is the A input. We already discussed about the circuit diagram, that is we get the expression like that, A into B plus C. So this is the A, so this is B input, and now it is C input, and the output of the B and C is connected to the AND gate. So we connected the AND gate, and then we connected the AND gate output to the LED. So this is our combinational circuit diagram. So firstly we join the give the power supply, here positive and here negative. So firstly condition we will satisfy, that is 0 0 0, so we get the 0. Then we satisfy the second condition, that is 1 0 1 0, and its equivalence decimal number is 10, so we get the output will be 1. So let's check it. This is the A 1 and this is B, we can 0, and C is a 1, so we get the output is 1.